What's going on, guys? This is Caucasian Mark, the whitest dude on the internet, and today I'm going to be talking about the primitive data types in Java. Now, I know the first few tutorials are going to be like really damn boring because it's all basics. What do you do with this kind of number? What do you do if there's a decimal? All that other stuff. Trust me, it is boring. I think everyone finds it boring, but it's the building blocks, and you have to learn it in order to be a good programmer, right? So let's get going here. The first type of primitive data type we're going to learn about is a thing called DBite. If I can knew how to type. And let's go up here and I'm going to show you something else that you could do. This is called a single line comment. You do 2 forward slashes and it just wipes out everything else on that line after the fact. So when you go to compile it, when you go to do anything else with the code, the compiler won't read it. And say someone wants to work on your program next, or you come back to it, you can see what you were talking about. And this is important for note taking, so you don't write some kind of program and you don't know what's going on later. But back to the point here. So a byte, its value ranges from negative 128 to 127, and this is how you create one below. So you're going to type byte, and then you have to create a name for your variable that you're going to use. So just for tutorial's sake, we're going to do first byte equals, and let's say 128. Then we do this, and we see that we have an error, right? Well, if we look up here, it goes to a negative 128, but only goes to positive 127. As we could see, we assigned a much larger value than the data type could hold. So let's go to the max here and do 127, and we see that everything's fine. The red mark that was here is gone now, and we can continue on to our next primitive data type. So the next one we're going to be dealing with is called the short, which its range is much larger. It's negative 32,768 to 32,767, so a much larger number. So let's come down here, write down first short, and let's give it a value of 30,666 because we love the double. Now, as we can see, we've created an error here. Now, why is that? And when I'm typing numbers, when I'm not coding, I like to use commas, right? Because it's kind of a nice marking to show, what kind of value you're trying to pass in. Because let's say there's a lot of ones and zeros in your number, it may get kind of confusing. Well, you can do this, but you're going to have to go back and delete this comma here. As we can see now, the compiler could read it, and it's going to be the same whether you use NetBeans, something from JetBrains, Eclipse, whatever have you, solely because it doesn't read that as a number. It'll be reading it as a string, which we'll talk about later on. So if you're going to use a large number and you have to use something like that to keep track of, are you in the hundreds or the thousands or hundreds of thousands digit, that's cool. You just have to go back and delete them later. After a while, you won't have to do that, but I'm letting you know off the bat, that's a big no-no. So we have our short and we have our byte here, but wait a second, let's look at this. It's a lowercase first there, but when we get to the second word, it's uppercase. Now, why are we doing this? This is called Camel Caps, and it's very important because we can't go in here and type first short. Why? Because the compiler will know that this is a short number coming in, but what does first and short mean? That doesn't make any sense to the compiler. So you kind of have to jam your words together in a sensible and meaningful way so you or another programmer could come in and realize what type of variable that you're using. For this case, we can see we're using first short, and so we're going to lowercase the first word, we're going to uppercase the second one, and if we were to do a third word on there, we would do first short number. Whereas if we had to go back and do it like this, that kind of all blends in together. You might autofill in your mind what the variable name actually is, and it gets kind of muddy and confusing after a while. So you don't really want to do that whatsoever. I think one of the most important things about being a programmer is giving meaningful and legible names to your variables and methods we'll learn about later, because readability is key in your code. You don't want to come back and not know what the hell is going on. So after that long one comes the very next and I think most important data type of all the primitive ones, and that's the int, which is integer. Now this is going to take quite a while here, so let me go over to here and I'm just going to copy and paste exactly how long this number is. Easier than typing it out. Come back here. As you can see, the comment only does one line here. So we're going to bring it back over. And this is a freakishly large number, right? I wish I had that much money in my bank account. I don't. Maybe after a few years of YouTube I will. But just keep in mind here, you're starting to see kind of hopefully a pattern that different numbers hold different amounts of data or number sizes in them. And you're going to want to keep this in the back of your mind while you're programming, say, a clock or some kind of application or even a game. You want to be aware of what the max and min size of data you're going to be intaking, or potentially the amount of users you may be having in a database. And you don't want to under or even sometimes over prepare because of memory and how long it takes to run certain parts of your application. So you kind of want to be wary of what data type you are using for the maximal efficiency and less errors in your code. So if we're going to make an int, let's do this. I love ints. This is I love ints, short for I love integers. And let's just give this a value of that. So what we're also looking at here is you could be thinking to yourself, well, we have first byte equals 127, first short number equals 30,666, and so on and so on. But that's not meaning equal when it comes to programming. What you're doing is assigning. That equal sign is an assignment. So rather than saying equals it, which in layman's terms when you're first starting off you could think it equals it, but what you're really saying with that equal sign is assigning. We're assigning the value, we're putting it in from right to left into our variable name. So rather than this going this way, saying this equals that, what we want to be thinking is this number goes into I love ints. 30,666 right here goes into first short number, and that's the new value of that variable name we have. And that's a very important distinction. Are there things such as equal statements or testing to see if two things are equal? Yes, and that's a different symbol than what we're using right here, although it looks very, very similar when we get to that point. That's something that held me up a little bit when I first started programming, because I wanted to take symbols I've seen in regular day-to-day life and use them in the literal meaning, when really they kind of have a bit more of an abstract or a secondary defined term that we have to use all the time when we're thinking like a programmer. So the next one we're going to go to is a float. Now floats are interesting because these are decimal points. And so I'll show you for a second here. So first float number, let's do, I don't know, 10.465. And we see we get an error there. Now, the width of a float is pretty respectfully large as well. It's about the same number of bytes as a integer, but I'm not going to type them all out for now, because the more important lesson here is why am I getting an error right here for first float number? It seems I declared the data type correctly. I have a sensible name here, and since it's a floating point, which means it takes decimals, what's wrong with this? Well, we have to come in here and we have to type F. This is telling the compiler that this is a floating point number, which is required because we have the data type name over here. That's a must. You have to do it when you have a floating point number. So if you're ever going to use a decimal that is a float, always keep that in mind as well. So the next one we're going to have is a double. And a double is 8 bytes, and it's another freakishly large number as well. So we're going to skip the whole, what's the range of it, because we're dealing with decimals here. It's easier to do when you have, just a solid negative 128 to 127. But it's kind of more of the same when it comes to floating point numbers, decimals, and whatnot. So let's go to first double number. We can do 10.465. Awesome stuff there. So this is much, much, much larger data type than a float is. It can hold a much wider breadth here, but for floats you may want to use either smaller numbers or smaller floating points, anything along those lines, because there's a definite difference in data precision between the two. Now another interesting thing that you may have noticed is at the end of all of these I am typing these semicolons here, right? Now what are these semicolons? Think of them as a end of a sentence, like a period you may use, or an exclamation point if it's your last line of code and you spent hours trying to figure out how to get it to work and you're like, God damn it, I'm done, I'm going to type that, right? You could treat it as like a period at the end of the sentence, or I should say you think of it in that way. So whenever you're done writing your line of code or your method, you're going to end your statement with an exclamation point. Otherwise, you get an error because it's saying, hey, is there more going on? Is there more I don't know about? And the compiler must know that. Otherwise, you're going to get an error and your program just flat out won't run. Now coming down in here into a char, char, some people pronounce it differently. It's a character. This is a 2-byte value, so it's this range is pretty respectfully large. But if we had to use it, say, to, I don't know, hold a single value, we could do something like this. First char or char, or whatever side of the boat you're on. One of my friends says it's a char. I like saying char because I like calling it by how it looks. No one really gives a shit at the end of the day. And let's do A. Now we can see there's an error here. Now why is that? Why can't I hold A in there? Well, if we come over and we do that, that is still incorrect. Why is this not working? It's because we want to use the single quotes. You'll see double quotes later on, but if you're wanting to store a value in this data type, you're going to have the single quotes around it so it will work. That's pretty simple enough. And the last one is a Boolean, which is true or false, or we can even think of it as is or is not the case. Because sometimes you can't say true or false when you're testing a value. You want to say whether or not it is or is not the case. Because sometimes linguistically it makes more sense to speak in different terms of true and false rather than always definite true or false. And you'll see why later, but sometimes you have to, if you're testing if this is a value, you want to say is it true or false, but sometimes it's easier to say is it or is it not the value that is expected to be assigned for, say, X or first double number. That may sound confusing, you'll get it later. So we're going to type Boolean value, and can we do this? No, we can't at all. Can we put buts in there? Absolutely not. But what we can do is true. We'll come down here again, Boolean second value. Once again, these aren't good names for these variables, but they're good enough to show you examples of the basic data types. And so we have Boolean second value, which is false. And these are the only two kinds of values that will be going into your Boolean data types. And these are really good for checking any kind of logic you may have in your program, rather than testing numbers which may change or other variables may change them. Booleans are simply true or false, and they're actually a lot of fun to use later on in your programming. But like, share, subscribe, contribute, leave an awesome comment below if you have any questions. My name's Caucasian Mark, and this has been Primitive Data Types.